All right, so I had originally thought to do 8.2 and 9.1, but I was looking at 9.1, and like 9.1 really needs you to have worked with the 8.2 stuff a little bit. So we're just going to do 8.2 today. 8.2 is on sampling distributions for sample proportions. Now, this is a similar premise to what we had before with the sample mean. The big picture here finding out the true proportion for a population is a pain in the ass. It really is. You got to ask everybody. But it turns out we can use a sample to determine a proportion for that group. Since each sample has different responses, will likely have different proportions. The sample proportion is a random variable. And thus has a probability distribution. This is kind of like similar to what we said with the mean for 8.1. This is what we want. This is good. Because then, assuming some criteria is met, which we'll discuss, it will follow a normal distribution. And all the techniques we are going to learn work really well. We start learning those techniques in chapter 9 onward. Chapter 9 onward, we will use those techniques. To infer the proportion or the mean, like for 8.1, for the population. That's where we're headed. You guys having fun writing? I give you a good wall of text. But now I think most of our multi or long sentence writing's done. I think we got the big picture out of the way. I can get away with just short little like sentences from here on.
These techniques or those techniques? In the red.
Those.
Okay, gotcha.
That's just big picture shit that you can read later. Okay. Now that Angel's here, we can start doing some math. No, I needed to go over big picture shit. I normally distribute it out throughout the thing, but I figured, you know what? I finally, like, every time I teach this, I get a little bit more concise and worded a little bit better. And I think just nailed it. We got the whole big picture going on here. All right, so what's our map? Well, proportions look like this. P equals X over N. We've been doing this for a while. Number in the group. Number with the trait. Over the sample size. We call this P hat. P hat. P hat is the point estimate. It's the P we think the population is going to be close to. So previous semester, I asked students what they thought of Luke Skywalker. In episode 4. Like the first movie made. And I gave them 4 options. I said, do you think he's a whiner? Do you think he's heroic? Do you think other? And I put in an NA for people that have not seen Star Wars. And so they didn't have to end. Like, I don't know. I don't know who likes Luke Skywalker is. It was anonymous, so I didn't know who to fail right off the bat. That's a joke. You don't have to have seen Star Wars to get through this class. Now, I don't know if it's because they heard me bitching about Luke Skywalker, but 33% he was heroic or whiner. 9 said he was heroic, and nobody responded for any of the categories. We could see that adds up to 42 people if we add those up. So the point estimate or the proportion of the population that think Luke is heroic is 9/42. That's what we're talking about with the point estimate. What I mean by it, we ask a sample, we get an idea for what the sample says. And then we're going to say, well, we think the big picture, the population is close to it. And we're going to come up with a likelihood of that happening over the next month or so. We'll start looking at the likelihood of that happening. Now, does anyone need this a longer?
Yes.
All right. You do you. Good. Okay. So that's the big picture. I said we want the sampling distribution. Sampling distribution to follow a normal distribution. For this to be the case, two criteria must be met. And these criteria are easily determined in a calculator. A, n times p times 1 minus p needs to be greater than or equal to 10. I believe we've seen this before back in, I don't know, chapter 6 on binomial distributions. And the other criteria we need to have met is n is less than or equal to 5% of the population, big N. Now, if these are true, we can use our normal calculator. Stats, calculator, normal. And the mean we will use for the proportion is equal to p hat. And the standard deviation for the proportion is going to equal, this is a pain in the butt, but it's still doable in the calculator. P times 1 minus p over n, and then you take the square root. And when you're doing it, you will have, it gives you like, remember the normal calculator will say probability that X is less than or equal to blank. This is really the probability that P hat is less than or equal to blank. Because they don't change the letter. It stays X all the time. All right, if these aren't met, well, the easiest thing to do, best choice, N is probably too low. And we're going to see an example of this today. We're going to do the homework, some of the stuff in the homework, and you'll see it. And it's probably too low, so ask more people. If you can't, the binomial calculator will still work. Is what you have to use. Are you guys ready? All right. We're gonna look at a couple homework problems and we're actually gonna be done. It's kind of important that you do the homework for chapter 8 so that you can get a feel for what the hell we're doing in chapter 9. So we're gonna actually do a couple of them in class. I'm gonna walk you through them. And they're all pretty much the same. Like almost identically the same, basically just different numbers and shit. So when there's only 10, I'm gonna do 2 of them with you. Do 8.1 and 8.2 this weekend and you'll be good to go for it's all simple calculator math. Does anyone need that longer? All right.
I do have a question, on the 7.3, because I was looking at it, I know you said it was tied into one of the chapter, the 4.2,
Yeah,
so, I mean, because I know we took notes on, I was trying to do the homework, but I couldn't find it, so it's combined in with 4.2, right?
we did 7 points.
I have it, I know, I'm gonna catch up on it,
No, we actually lectured on 7.3.
Yeah, so, but is there any homework that ties in with it? Cause
Yeah, it's well, I'm about to go over to the homework page, so we'll take a look.
I couldn't access it for some reason.
Right there.
I must have just overlooked it. All right, I'll take care of it.
It's
Thank
there. All right, 8.2. So question 1 says. Describe the sampling distribution of p hat. Assume the assume the size of the population is 20,000. I'm gonna write down the information it gives me. Number 2 is very similar, just different numbers. So it tells me little n is 800, p is 0.3. And the population, which is big N, is 20,000. Now you'll notice if you look at the responses, they all mention n less than or equal to 0.05 big N. And they all mention n times p times 1 minus p. Some of them say less than, some of them say greater than. So we're gonna work it out right now. The actual one you gotta make sure is the greater than. That's what we want. Those are the 2 things we want to have happen. So we are gonna make them happen.
What are the two things again that we want to have?
These two,
Okay, thank you.
those have to be true. If these are true. The sampling distribution follows a normal distribution. So they gave us numbers, let's give them a try. I have 800 is my N. That needs to be less than or equal to 0.05 times 20,000. And 0.05 of 20,000 is 1,000. So yes, this one is met. Then we check N times P times 1 minus P is 800 times 0.3 times 1 minus 0.3. Is that greater than or equal to 10? (800) times 0.3 times 1 minus 0.3 is 168. 168 is greater than or equal to 10. So this follows. It's approximately normal. Both are met. Thanks. So of the options we have, we want the one that says approximately normal, but two of them say that. Both B and D say approximately normal. They both say because N is less than or equal to 0.05 N. The only difference is the N times P times 1 minus P. We want greater than or equal to 10. So that is option B. Now, yeah.
You probably already answered this, but how can you distinguish when it's normal?
How do we distinguish when it's normal?
Because the one that answered is approximately normal and the second answer is not normal. How can you distinguish those?
That's what we were doing. if one of these is not met, like one of these makes a false statement, like if I ended up with 2,000 is less than 1,000, that doesn't work. Then we don't have, then it's not normal. Usually the one that fails is this one, if any. Okay.
Makes sense. Thank you.
Mhm. And if that were the case, it's probably A. You can't assume just because my answer had it working, that when you do your problem, it's gonna work. So if it doesn't work, it's probably the n times p times 1 minus p. It probably was not greater than or equal to 10, it was less than 10. And so if it doesn't work, it's probably A. C doesn't ever make sense. Because it says because n times n is less than or equal to 0.05 n and n times p times 1 minus p is greater than or equal to 10. If both of those are true, it is approximately normal. So C doesn't ever work. So it's either B or A. Those are the only two ones that make sense.
Is there ever, I think I see that I questioned too, like, is there ever a case where it's completely normal? Or is it always gonna be either approximately normal or? Since it's a population.
There are, well, sometimes like if we did IQ, something like that, something we know is a normal distribution, yes. Betsy, it may tell you it's a normal distribution. If it tells you right away the population follows a normal distribution, you don't need to do this test. So let me add that over here. They usually don't have that, but if it is known that the population follows a normal distribution, this test isn't necessary. But usually it's not, because if we already knew, we probably already know the proportion, and we wouldn't be doing this in the first place.
Okay, sorry.
Does that make sense?
Yeah,
Is it more or less like when it's like symmetric or whatever, when it's like half of the population is above average, like that? Like in-
Yeah, the normal bell curve has that symmetry. That's what we're looking for. None of the other distributions have that symmetry. We're looking for that symmetry that comes with the bell curve. Like Poisson has a hill. It really does, but it's off center. The Poisson distribution is a skewed distribution. Binomial is usually a skewed distribution. But if you're doing this sampling distribution off of sample groups, it's kind of like it makes it, it's the magic that makes it work. And generally, you just got to take n large enough. As you'll see on the next problem. So this one was approximately normal because we met the criteria. I'm going to come down and look at problem number 6. I did this already and I marked it as done, and then give me a new one so that you guys will see it with fresh eyes. So this one says a researcher studying public opinion of proposed social security changes obtains a simple random sample of 50 adult Americans and asks them whether or not they support the proposed changes. To say that the distribution of the sample proportion of adults who responded yes is approximately normal, how many more adults does the researcher need to sample in the following cases? It sounds like he hasn't asked enough. So I'm gonna pull like the important pieces of information from this. It says 50 adult, the sample is 50 adult Americans. That's my little n. And I know you can't see what I'm writing, but I will get back over to it in a second. My little n is 50 adults. And it asks how many more should N be? That's what it asks for both scenarios. And it gives two scenarios, 15% and 20%. And we want it to be approximately normal, which means, again, I'm just gonna keep rewriting it so that it sinks in. N needs to be less than 5% of the population. And N times P times 1 minus P has to be greater than or equal to 10. It just feels weird the way they said 50 adult Americans. I would probably say 50 American adults. But that's just me. "50 adult Americans is definitely less than 5% of the population of the American adults. Right? It's way less. I don't need to know what N is, but I know that it's less. This is like the top one's a freebie. So this one's a freebie. If they said like, I don't know, 10 million, then I need to go look. I don't know. That seems like a lot of people to fucking sample. 10 million people is a lot of people to ask questions of. So what we're checking is this one. We need this one to be true. So, and they're saying, let's just see if 50 is enough. This is P equals 0.15. And this is P equals 0.20. Let's test the 50. 50 times 0.15 times 1 minus 0.15. I'm getting 6.375. And is that greater than or equal to 10? No. It's not greater than or equal to 10. So 50 is not enough. So what we're going to do is we're going to leave N as an N. We don't know what N is. We're going to calculate N. We're going to leave that as a variable. And we need that to be greater than or equal to 10. And we're going to solve this equation.
Can you go? So you did the 50, the 15 and the other 15?
This is my P and this is my 1 minus P. And that's my N. So I'm doing part A here. Does that make sense? Or did I answer your question or did I not answer it?
So it's not so, that's what I'm calling this. 50 times point.
It's times, yeah. When we do the parentheses, that means multiplication. When you have a number in front of parentheses, it means multiply.
You would do.
Yeah, I did 50 times 0.15 times. I actually calculated that and I had 0.85. I did that. If your computer or your calculator has parentheses, instead of doing 0.85, you can do 1 minus 0.15 and hit parentheses and then do the equals. So you either need that part or that part. And in fact, I encourage you to do that on your calculator right now. Make sure you get 6.375. Make sure Hefe isn't talking on his ass, because he's been known to do that. In fact, he was doing it a lot in the last hour. You guys missed some funky trumpets. It was some good action going on in here. Kayla, are we good? Yeah, am I not, do I need to explain it more?
That was good. I'm just, what I was doing was, I have the same problem, but the different numbers, and so I'm trying to go by your steps and do my problem too,
Okay,
so I understand it differently.
okay. So. What we're gonna do is similar to this one, we're gonna just leave n alone now. And we're gonna solve this. So. 1 minus 0.15 is 0.85. Then we're gonna multiply those two together and get a number. 0.15 times 0.85 is 0.1275. Or if I write it like I've been showing you guys in the sport course, we would have it like this. Put the number in front. And we finish that bad boy off by dividing by 0.1275 on both sides. That will get n by itself. And I'm getting n is greater than or equal to 78.43 more and some change. There's more numbers. I need n to be greater than that, and n is the number of people. So that it doesn't make any sense to have any decimals whatsoever. So we're gonna round up to the next whole number. N needs to be greater than or equal to 79. That's not my answer, though. He's already asked 50 people. Or she, it doesn't indicate a gender. They already asked 50 people. So how many more do they need? $79 minus 50 is 29. And if I come over, says okay. Amount I want to know 20%. So I want you guys to try that before I do it myself. Try to find n when p is 20%. And figure out what I need to answer. Another 60 seconds, we'll do it together. All right, let's take a look at it together. And I'm looking at n times p times 1 minus p. This is n times 0.20 times 1 minus 0.20. And 1 minus 0.20 is 0.80. 0.20 times 0.80 is 0.16. Yeah, 0.16n is greater than or equal to 10. So we divide by 0.16. I get n needs to be greater than 62.5. Which means 63. We can't have half a person. They already surveyed 50. So 63 minus 50 equals 13. 13 more people to survey. And with that, the lecture is done. You can get the fuck out if you'd like. GTFO. I will not be there at Starbucks this weekend. I'm getting my wisdom teeth pulled. So while you are having a lot of fun doing math homework, you can take joy in the fact that I will not be. Unless I take the codeine or whatever they give me. Then I'll be high as a kite and I'll be happy to be. Right. Please, please, please do chapter 8 homework this weekend. We just did 2 out of 10 in class and the rest are very, very similar to this.
Thank you. Thank you.
Uh-huh.